Not sharing the screen. Now I am sharing. I hope you are able to see this. Right. So what we are going to discuss now. So in this session, we are going to discuss about the basics and fundamentals of Docker. Okay. So if we want to go ahead into the concept, first of all, you need to understand the basic primarily three things. One is server, virtual machine, and container. Okay. If you understand these three things, then proceeding ahead will be very easy for me. So if you see, these are the three different concepts, whatever you are seeing. So these are all the three different concepts. So it's like a very big library. Inside the library, you are about to study something new books. Okay. So server is a new book, and what I can say, virtual machine and containers. These are the three different new books that you are going to study. Now, those people who knows about that, what is the main fundamental difference between servers? That's okay. So these are for the things. These are for the guys who are currently, who are newly understanding about the IT industry, and who are newly joined into this sessions. So now when we are discussing about a server, okay, so when we are discussing about a server, just think it is like a very big home. Okay, so it is like a very big home, and see, if it is dedicated to a single person, so that's a very big villa is there. Okay, so when the very big villa is there, and this villa is dedicated to a single person, now what happens here, this villa space is used only by a single person, or else the resources that are in that villa will be used by a single person. So what happens? New tenants cannot be added into this. Why? Because it is agreement. There is an agreement that only one person should be there. So in the same manner, when you come to the physical server, a physical machine dedicated to run the application. Okay. So a physical machine dedicated to running the application and storing data. Okay. All resources are used by one operating system. Only one operating system will be there. So inside that, we are going to run the applications. Okay. So if you see the pros, dedicated resources. Okay, so to run an application, all the applications will be running on a what I can say, dedicated resources. So those resources will not be shared with the another application simply. Okay. Also another application, or else what I can say, for example, you have written a code for one Java application. So only one Java application will be running, or else one Java services, multiple Java services will be running. For example, if you see, we have a banking application, or else we have what I can say, e-commerce application, where there are so many microservices are available. All these microservices all together we will call it as a application. So simply, if you see, I think in your mobile you are having Uber. Okay, how many people are having this Uber? So if you see, this is the Uber microservice management system. If you can see, So the whatever the Uber application that you are having, so which is a what I can say, service taxi application. So you are having only a small application in your mobile. Okay, it's a small icon in your mobile. But if you see the back end, so this small application is having multiple services. Whenever you are trying to access any sort of microservice, okay, you will open the Uber application from by just clicking on your mobile. The application will be opened and you will select the car. Okay, but the point here is, on that application there are so many microservices are running. So like API gateway. So whenever the user communicates, or else whenever the user try to access the service, first the request will be hitting to the API gateway. Okay, so whenever you request that to I want a ride. Okay, so first your request. So it will ask you, it will try to understand who you are. So then what happens? First it will go to the API gateway, and from the API gateway, if you are logged in, okay, so if at all if you are logged in, then it will fetch out your details. If at all if you are not logging in, then it is going to ask you provide your username and details. So that comes under the user management. So then what happens? Then it will go to the driver management. So which means you have to find a driver. Okay, so now what happens after the passenger management? It will ask you for the passenger web UI. Web UI is nothing but it will ask you for select the destination location. Okay, so your location and destination location, how much fare it is going to have tip, and then it is going to find a driver for you. Okay, so once it find out the driver, then what happens? Then the request will go to the driver UI. So then the driver will accept the trip and the trip will be started. Once the trip is started, then trip management will be done, and finally payments. So billing and payments and notification. So like that you will be having multiple services. Okay, so this is one of the small microservice architecture of the simple applications, Uber application. Likewise, there are certain banking applications which should be first hitting. So API gateway, what is API gateway? API gateway is nothing but API is application programming interface. Okay, so application programming interface in the sense, whenever if you want to communicate with any application in the backend, if you want to communicate with any small services of that application, first of all your request will be hitting to this API gateway. Try to understand. So it's like if you want to go inside an office. Okay, it's like if you want to go inside an office and you want to meet some HR, or else there are so many another departments. You want to meet some system administrators, you want to meet some developers, you want to meet some testers. So there are so many number of references of employees are available inside a company. First of all you have to reach to the receptionist, or else first of all you have to come across the security. From security you have to go to a receptionist. So here API gateway will be like a receptionist. Okay, so you will go to the receptionist and ask that I want to meet HR. Then the API gateway will take your, I mean, the receptionist will take your request and forward it to particular department. Okay, so there is a person who came to meet you. So once they have approved, then you will be sent to that particular location. So the API gateway work is like a receptionist. Okay, so why I am saying you this particular diagram here means, so for a single application, so whatever the applications that you are seeing, like VLC media player, or else what I can say, uh, any installable applications. I am not talking about those installable applications. So there are certain applications which you are running on the server. So those applications will have multiple microservices on all combinedly together called as a single application. Now that application you can run dedicatedly on a single server. So that single server will provide the resources for the entire application. Okay, are you able to catch my point? Any questions here? Are you able to understand? First of all, guys, are you with me? Hello?
Yeah, Chaitanya.
Yeah. So now that is how your server will be. That will be dedicated to a single application. So high performance for a specific task, and what will be the cons, which will be, so there will be a positive side and there will be a negative side. The negative side will be expensive to set up and maintain. So if you are having a server, so first of all you need to pay the entire amount. It's like an upfront cost, somewhere around 3 lakhs to 4 lakhs, 4 lakhs rupees you have to purchase. And limited flexibility and scalability. Limited flexibility and scalability in the sense, for example, I want to have an another instance of the application. Then now again I need to purchase the another server, so which is again a cost effect, a cost incurring thing for me. Okay, so I cannot go multiple services or else multiple servers. So I don't have that scalability and flexibility. Next one is virtual missions. When you come back to the next concept, the next concept is like virtual missions. So what is a virtual mission? So if you see here you can see an apartment. Previously, when I say it's a single villa or a single house, but if you come back to the next topic, it's like an apartment. So what is the apartment? So physically you will have a single entity. Apartment is nothing but a very big building. So inside that, what you will have, you will have multiple floors, and in multiple floors you will have multiple houses. Okay, so in the same manner, when you come back, it's just like an analogy I'm telling you guys. So you will be having a physical server. So so one physical server, and that physical server is like divided into small multiple virtual machines. Okay, so from where it is going to consume the resources. So these houses, okay, whatever the houses that are created inside the apartment, from where it is going to grab the land. Of course, it is going all houses that are created in an apartment will take the land from the apartment area itself. Okay, so physically how much land that apartment is having, or that much amount of land only it is going to consume. So if you see here, the virtual missions are like an apartment. So where they are going to be created. Okay, so multiple computers will be created inside the single physical server. Okay, so multiple logical servers will be created inside a single physical server. So if you see the diagram over here, you will understand. See that. So a virtual machine is a representation of physical computer. Multiple VMs can run on a single physical server, each with own OS. So here I am having a physical server. Okay, physical server 1, physical server 2, physical server N, or else physical server 3. Now all these physical servers will have its own virtualization software installed. So for example, so virtualization software, in the sense, there are two types of virtualizations. First of all, you need to understand this. So virtualization is of two types. One is type 1 hypervisor, or I can call it as bare metal hypervisor. Okay, and the second one is type 2 hypervisor, or else I can call it as a hosted hypervisor, or else hosted virtualization. Now, what is the main difference between these two? So what is the main difference between bare metal and hosted? So up to now, whatever we have discussed is all about a single server. So I am having a single server. If I want to host the application, sorry. So I'm having a single server, and if I want to host the application, the resources will be consumed by the entire server, or the application will consume the resources from the entire server. So that's the main point. Now, what will be the drawback? For example, there is a server which is of some 16 virtual CPUs or 16 CPUs, and somewhere around 256 GB of RAM is there. Okay, so 256 GB of RAM is there inside a server. So server is nothing but a very big computer. Okay, just to try to understand like that. It's not true, but the point is, for to make you understand, I am saying you this. So what is a server? A server is like a very big computer which will be having high amount of resources. In your laptop, you will be having only for one CPU or 4 GB of RAM. Okay, or else octa-core processor 16 GB of RAM. Maximum it will be there only 16 GB, or if you go ahead, it will be like 32 GB of RAM for client side, which means in your laptop you will be having 32 GB, 16 GB depending on the requirement. Okay, so you are going to purchase the laptop maximum nowadays in the in the market you will be getting some 16 GB of RAM laptops. Okay, so but that 16 GB, whatever the laptop that you are having, so only you can access that. Only a single person can access that. So whatever the resources that are there inside that laptop, only a single person can access that, and he can install the application. He can run the applications inside the laptop. For example, I want to host an application. So what is meant by hosting an application? For example, I want to create a website. Okay, so if I want to create a website, or else if I want to create a web application, so for that so many requirements will be there. So whatever the web applications that you are seeing, so see, web application in the sense only front end is on not will be there. So for example, there will be, if I go for amazon.in, or else for any banking website also. So why I am telling you banking, because I work in banking sector. So HDFC Bank is there. So whatever the HDFC Bank that you are seeing, the front end, so this front end will be created with three different constraint, or else three different servers will be there. One will be the UI server, which will be giving you the front end web page, and the second one will be the application server. So the back end code for this entire application will be there, and third will be the database server. Okay, so to just to show you this single application, or else to make you log in into your required account, so we need to have multiple what I can say, servers. We need to have multiple servers. One will be the UI server, app server, and the third one will be the database server. So I can call them as a three stages of, or else a three-tier architecture. Okay, so the first tier will be UI, user interface, so which you are seeing in front of you, and the second one will be the application interface. Okay, or else application type. So where there will be application servers, which means I want to log in into my personal account. Okay, simply I will go with what I can say, is there any login available over here? So let me check. Yeah, login net banking. So in the backend, when you click on this, you have to go to the particular application that will be written over there. So here you have to give the customer ID. So for example, my customer ID is 1234567 8. So when I give this and click on continue, now what happens? It will go to the database. Okay, so it will go to the database and check for the user ID, whether this user ID is there or not. So if you see here, I am giving the data in the front end. So the first tier is UI tier. So I am interacting with the UI tier. The user will actually interact with the UI, okay, user interface, and provide certain data. So when he clicks on continue, that will be what I can say, that will be hit to a particular application. Okay, back and it might be what I can say, JavaScript, or else it might be Java related application. So it is going to hit to that particular application. So once it is hitting that application, so once this data is hitting that application, here first two tiers are completed, UI tier and application tier. Then automatically the request will be sent back to the database. So whether the user is there or not. So if the user is there, it is going to give you the response saying that provide the password. So here you can see there is no user ID, so it is giving you an error. So if you see here, in just in a simple span of time, we have seen three-tier architecture: tier 1, tier 2, and tier 3. So this combination you will have the applications. So if you see how many things that should be running to create, or else to run an application, you need to have the web tier, you need to have the application tier, and you need to have the database tier. Now if you try to create all those things in this server, sorry, all those things in this in this physical machine, whatever the client machine that you are using, or else whatever the laptops that you are using, So it will be very hectic for your laptop. So inside your laptop itself, you have to run the web, you have to run the app, and you have to run the database. And apart from that, on the top of that, there will be several connections. Why? Because the application will be there right now. I am not only the person who is trying to log in into HDFC Bank. There will be some thousands of people who will be hitting the HDFC Bank right now, server right now. So which means that there are so many connections that will be coming to your laptop. Okay, so this particular laptop or desktop, whatever you are using, only the client related operating system, so that cannot communicate, or else that cannot withstand these many number of functions at a time. So what your client mission has to do, your client mission has to run the multiple types of application, and then it has to respond back to the multiple users, so which cannot be done. Okay, so to overcome that, for example, we are habituated to an hi-fi life. Okay, so we are habituated to an hi-fi life. We cannot do very very physical work right now. Okay, so in that case, for example, if any one of you was anyone was given a job like a server. So if you go to a hotel, and just for one day you have to act like a server. So that is what the challenge is. So now if you go into that hotel, so restaurant, simply I will call it as a restaurant. So in restaurant, multiple people will be coming. Okay, so we don't have that tendency to answer all the people requests. Okay, so there will be so many customers that are coming to the restaurant. You have to go to each and every customer, and you have to ask what is your requirement, and you have to supply those requirement to those customers. So you have to work so ruggedly. Okay, so that cannot be happen. So why? Because we are very habituated to sit into an AC and sit in front of the computer and just to work. Apart from that, we don't have that physical activity to work like a server. Okay, so in the same manner, my whatever the laptops that we are having, whatever the desktops that we are having, those are just for a small purpose, not for giving responses to the thousands of requests, or else lakhs of requests, and running multiple applications at a time. So it cannot be done with the client laptop. Okay, client laptop, or else the desktop which you are using. So for that reason, we will be going for the servers, where there will be huge amount of resources. Okay, there will be huge amount of resources, which means that just compare. I'm trying to say you. Of course, we are also a corporate laborers right now. Why? Because 70 hours of work hours that are coming ahead. Of course, we are also the corporate laborers. But when you compare to us and the people who are doing the physical hard work, there is a small difference. We cannot do that much of hard work how they are habituated to. So whatever the things that are allocated to us, we have to do that, and whatever the things that are allocated to them, they have to do that. So just try to see the difference. In the same manner, whatever the work that is given to your desktop, it has to do that work only. So if you say I will convert my desktop as a server, of course it can be converted, but try to understand how many requests it has to respond back, and how many applications it has to run on the given limited resources. It cannot be done. So for that reason, we are going back to the server concept. So inside the server, there will be huge amount of resources, and it can run multiple applications at a time, and as well as it can respond back to the multiple users at a time. So that is why we are going for the physical server. But the main problem here is it can allocate only a single operating system. So for example, I'm having an application that will be feasible, or else that will be compatible with Windows operating system. But inside the server, if I install the Linux operating system, then it will be a problem. Then it will be a challenge for me. Why? Because the application won't run on this server. Okay, so for that, what I have to do, I have to purchase a very new brand new server. So that is one of the problem. Dedicated operating system will be there. Okay, so if you want another operating system, you need to have another server. That's a problem. And the next one is you are running an application. So the application, whatever the application that you are running, so it is going to consume the entire resources of your server. Whatever the 16 GB 250 sorry 16 CPU to 256 GB of RAM is there, it is going to consume the entire resources. So which is not required, which is not recommended. So some applications or else all the application won't require 16 CPU 256 GB of RAM. Why we require that? In the peak time, for example, I used to work for a company which is a share market company. So we have designed an application. So they design an application and we will monitor that. As a system administrator, it is my work to monitor. So if you see in the peak hours, like in the morning time when the share markets are about to open, at that time only there will be a very high load on the server. So once share markets are open, then automatically the application resource consumption will be reduced. And once at the closer time of the share markets, again what happens? The application resource consumption will be high. But it is not going to, the application is not going to consume the entire resources. The consumption will be high, somewhere like some 32 GB of RAM like that. So in the day, in the entire day, so the application will only consume some 32 GB of RAM at the start and end of the session. But in the middle, what happens? It is going to consume only 8 GB, 16 GB of RAM. Then what about the other resources? Those will be wasted. So that is what a main problem with the physical server. So the first thing is multiple operating systems cannot be running on the single server, and as well as the resource consumption will be moderate, not optimally consumed. Applications won't be there. So this is the main drawback of your physical server. Okay. So to overcome this, in the IT industry, we have came across a solution called as virtual machines, which means like just I have given you, it's like an apartment. So in a single place, I am going to construct multiple houses so that I can give that to the multiple people. Previously, if you see, it's like an it's like a villa. So server is like a villa. Only one person can live inside that independent house. Simply I will call it as an independent house. Only one family can be residing into that independent house in that particular area. Okay. So the resource consumption will be easy. So if one people is there, then one family is there, then there won't be any problem, right? So that family can utilize the entire land, and they can have their own personal bedrooms. And so there will be huge utilization of like what I can say, there will be whatever they want they can do freely. Okay. But when you come back to the apartments, in the apartment, in the single land, whatever the land that you are seeing, in that you can construct multiple houses, and you can give it to the multiple families. Multiple tenants will be there. In the same manner, here inside a server, what I will do, this is the physical server. I can convert this physical server into multiple virtual machines, VM1, VM2. So in VM1, I will have my dedicated operating system, and in the another virtual machine, I will have Linux operating system, and another virtual machine, I will have some Sun Solaris operating system, and another machine, I will have what I can say, some Mac operating system like that. So what happened here on a single server itself? Previously, if you see, if I am using a single physical server, I need to have only one dedicated operating system. But now what is happening? That physical server, whatever the physical server, on the physical server itself, we are creating certain virtual machines. One will be running on Windows operating system, one will be running on the Linux operating system. So this virtualization platform is the fundamental for your entire cloud. Whatever the AWS servers that you are seeing, Azure servers that you are seeing, GCP servers, GCP instances that you are seeing, all are the babies from the virtualization platform itself. Whatever the servers that are running on your AWS platform, all are from the virtualization. Now, how many types of virtualization are there? There are two types of virtualization. One is type 1 and the another one is type 2. Okay. So understood about this up to now. Am I clear? Any questions here? Do you have any confusions? Any confusions, guys? Any clarity that you require? Am I clear with the concept up to now? Okay. Everyone. Okay. Fine. So let us get back to the next thing. So what is this type 1 hypervisor and type 2 hypervisor? If you see the diagram, whatever the picture that I'm trying to show you here, so there will be a physical server. On the top of that, there will be a virtualization server or else virtualization platform. Okay. So whenever we are talking about the bare metal, on the bare metal, what happens here? There will be hardware. See, to run any application, to run any operating system, to run anything, first of all, you need to have the resources, CPU, RAM, and storage you need to have. Without that, you cannot run any application or else any operating system. In the same manner, you will have the hardware. On the top of the hardware, directly you are going to install the virtualization software. Okay, either it might be VMware. So what are the virtualization softwares right now we are having on the marketers or else in the marketers? So what is this? This is the hardware where you will have CPU and RAM. Okay, RAM. On the top of these hardware, you are going to install the virtual machines like VMware. Okay, VMware ESXi. Okay, and then if you are using Windows, then there will be a concept called as Hyper-V, and there is an Citrix Gen servers. Okay, these are all the virtualization platforms that are directly that we can directly install on the physical server on the on the physical resources itself. We don't need any operating system. So they themselves will act like an operating system, and these servers will be connected to a, we cannot directly communicate with these servers. First of all, these servers has to be connected to a network, and from the network they are connected to the client machine in the sense a client computer. So the user will interact with this client computer. The user will interact with the client computer, and he can manage the servers. He can manage the virtual machines. So how many number of virtual machines that he wants to create on this server, and which type of virtual machines he has to create. Everything can be manageable by the client software that will communicate with this server. So on the top of this virtualization platform, what is going to happen? We can create a VM, which is nothing but a logical server. So this is VM, virtual machine. On the top of the virtual machine, what we can do, we can install an operating system called as guest operating system. Okay. On the top of the guest operating system, we can run the application. The same will have in the another server. So in the another virtual machine also, we are going to create one more virtual machine. We are going to create one more virtual machine, and this virtual machine will have its own guest operating system. On the top of that, we can run the applications. So can anybody tell me from where these virtual machines will take the what I can say resources? From where, for example, try to understand. So it is a virtual machine is also one of the logical server. So if this server has to run, from where it is going to consume the resources in the sense CPU and RAM. So here this is VM2. So here Linux operating system is running, Linux, and here application one, nothing but Java application, for example, and here Windows application is running, Windows Server, and here app2, which is nothing but some Node.js like that applications are run. Now, do you understand my question? From where these virtual machines will consume the resources? Anyone? Yeah, from the physical hardware, whatever the physical hardware that you are having here. So from this physical hardware, they are going to consume the resources with the help of the virtualization platform. So this is the bare metal. So the next one will be a hosted hypervisor. What is the hosted hypervisor? It will look as similar as this bare metal, but only one additional layer will be there. What is the additional layer? The additional layer is, You will have CPU and RAM. On the top of CPU and RAM, what you will have an operating system, either it might be Windows or Linux, any operating system. On the top of the operating system, you will have a virtualization platform. On the top of that, you will have the virtualization servers. Okay. So first things what you need to understand here is this is only helpful for you to run in the client missions. Not very hugely it will be used. So if I have to show you, let me show you that. So I'm having an VMware Workstation Pro. So right now I have a laptop. Okay, right now I have a laptop. If you see what is my what are my resources, if you can see here, I am having CPU which is running at some 3.2 gigahertz and memory is of 11.5 GB. Now when I turn on my server, okay, so this is my Windows 2019 server. Right now I am on the Windows 11. So this is my hardware. Okay, so what is my hardware? My hardware is somewhere around i7 processor, which is an 8th generation processor, and memory is of 32 GB of RAM. Now what I will do, I will try to start the virtualization. So here I have installed an VMware workstation on my operating system, which means the first layer is the hardware layer. On the top of that, what I have done, I have installed an operating system. On the top of the operating system, I have installed the but VMware workstation, or else I can go with the virtual box like that. So now when I turn on the virtual machine over here, so I have a separate virtual server, and whenever I am turning on, so automatically it is starting the VMware. Okay, whatever the virtualization server 2019 server, Windows 2019 server, it is going to install. I mean, already it is installed, it is running. So this is what it looks like. So on the top of the virtualization platform, you will have the VMs. On the VMs, you will be installing the operating system. On the top of that, you can run the application. So this is what happened here. Look at that. Actually, I am using 2009, Windows 11 client operating system. On the top of that, I have installed the VMware workstation. On the top of that, I am running the virtualization server. That is Windows Server 2019. See that? So this is the server interface. I hope you are able to see this. Now I'll simply log into my server and I can install whatever the applications that I want. So which means that from where it is going to consume the resources. Previously, if you see, my memory will be 11.9 11.9 usage is there. Okay, but now if you see the RAM consumption, it is 13.8, which means that the virtual machine is consuming the resources from my physical server or else physical computer. Okay, so if I shut down this, so if you see here right now, my server is consuming 13.8 GB of RAM. Let me do one thing. I will shut down this server. Okay, to shut down the server over here, which means that I am releasing the resources. Here you can see the resources will be released. Look at that. From 13.9, slowly after shutting down, again, automatically it has came back to the 11.8 GB. So which means that, so the servers, whichever are running on the virtualization platform, they are going to consume the physical hardware resources. Okay, so this is a practical interpretation for that. So this is about types of virtual machines that you are having. One is type 1 virtualization and type 2 virtualization. And type 1 is also known as bare metal, where it is going to be widely used on the servers, not on the client machine. Bare metal can be used on your Amazon, AWS servers, Azure servers, or else GCP servers, or else in your on premises also. On premises in the sense, in the company wherever you are working, if you are having a server, you can divide that server into multiple logical servers, just like I have shown you, with the help of this bare metal hypervisor. And type 2 is hosted hypervisor. Basically it will be used in the client missions, not for the servers. So you can use the hosted hypervisor also. So Basically, which type of virtual machines we will use means bare metal virtualization we will use on my company environment. So that is what a virtual machine is all about. So am I clear here? Do you understand what is the main difference between a physical server and a virtual server? Can anyone brief me the difference once? Hello. No, don't worry. I think every people don't know about all the concept. You don't need to worry about if I say something whether they will feel. So there is no persons like that. Just open up yourself. So what is the main difference? Do you understand what is the main difference between these two? Any questions or else any comments on this?
Sir, one quick question.
Sorry, your voice is not audible. Best thing is sharing of resources. Okay. Yeah.
So my question is like the for the like VM like virtualization server or whatever you have 1, 2, 3, the resources all of them are taken by the physical machine, right? Like let's say it's like 16 GB. Like this 16 GB will be divided into three like virtualization server, right?
Yes, yes. Then see what's your question in this. It is going to divide like that. Then there will be uh, see if you are running an application on a 16 GB server, so that application will not consume the entire resources. It is going to consume only 4 GB of resources. Now what about the remaining 12 GB? It will be wasted,
Right.
no? So
Hmm.
but I don't want that to be happen. So I want to make my system to optimizely used. So for that, what I will do, I will create some virtual machines. In one virtual machine, I will give some 8 GB of RAM. Inside that, I will create an application. In another virtual machine, I will give only 4 GB of RAM. Inside that, I will run another application. And if you see here, it's not a platform dependent. So previously, if you see on a physical server, whatever the operating system that you are using, so you have to all application has to be what I can say they should be compatible with that operating system only. But when you see here, now in a single physical server, what I can do, I can run multiple virtual machines. In that, I can create my multiple operating systems. No, so one will be a Linux based application can be run. One you will run a Windows based application. So there is no problem with the what I can say, you don't need to find a new server for a new operating system. In a single physical server, you can run multiple virtual machines which will be running the multiple operating system, and there you can run the multiple applications. So you don't need to spend extra money. So if you see the pros, better utilization of resources, flexibility to run the different operating systems on the same hardware, and cons will be requires more resources than containers. We will come back to the containers, slower to start compared to the containers. So cons is they are comparing with the containers, like I'm comparing with the containers. But if you see the pros, better side of that, so better, so there will be a better performance, there will be high consumption of your resources will be there. So that's about your virtual machine. Okay. So the next one will be
Sir,
container.
so sorry to ask it. So this two virtualization server, if they want to connect the server, like we need to work on some networking. Like how does that connect or something?
Basically, all the virtual machines. For example, I have created only one virtual machine in my VMware. Okay. So you see, I have only one virtual machine over here. Okay, that is Windows Server is there. Okay, so for this Windows Server, there will be a network adapter. So if I create, basically, if I create an another operating system or else another virtual machine, there will these two will be isolated with each other. My Windows Server and, for example, I am creating a new Linux server. These two will be isolated with each other, which means they won't communicate until if they belong to the. So here what I will do, I will go to the VM, I'll go to settings. Here you need to just change the network settings. So if you see the network adapter, I will create my own LAN segment, which means that my own network. So inside that network, they will communicate, or else you can select the bridge network. So there will be some network configuration that you have to do, but this is not the scenario which I am trying to say. There is a networking concept. There is a concept called as bridge. Bridge means physical machine or else physical server will have the same network connectivity with the virtual machine, and there will be natting. Natting means converting the physical network into the what I can say virtualization platform network. Okay, and the next one is host only, custom, like that you will be having certain networking terms. So if you want to make one virtual machine to communicate with another virtual machine, a small networking technique you need to use. So apart from that, basically those two are isolated with each other.
Yes,
Do
sir.
you got
Got
your
it.
answer?
Got it, sir. Very clear. Thank you.
So that's about the virtualization platforms and how you are going to utilize. And the next one is containers. What is this container? So either in the apartment or else in the single home, so anywhere you will be having rooms. Okay, you will be having hall, you will be having kitchen, you will be having master bedroom one and children's bedroom, or else bedroom one, bedroom two, and washrooms, like that you will be having so many different say partitions. Okay, so what is going to happen? You will be having a single basement. Okay, single home, single basement. On the top of that, you will have the different what I can say different rooms. One will be hall. So now what is the functionality of the hall? Means what you will do in the hall, you will have a sofa, you will have a TV, and you will have a very good table on near to your sofa, and you will sit and you will watch the movies, or else if any guests come, they will be sitting in the hall and you can have a talk. And when you go to the another room, you will have kitchen. So inside the kitchen you have utensils, and then your mother will cook over there. So whatever cooking things will be happening on that particular room. And when you go to the bedroom, so you know there will be a bed and you can sleep over there. So that's a different thing. A children's bedroom, it's a different functionality. So if you see in a single home itself, we are having different rooms. In the same manner, in a single server, now on the same basement, in the sense on the same operating system, we can run the multiple type of containers. So containers won't so previously, if you see the virtual machines will have its own dedicated operating system. First you will have the physical hardware, on the top of that you will have the dedicated operating system, on the top of that you will have the applications running. But when you come to the containers won't have any dedicated operating system. So you don't need to install an operating system over there. So you can simply use the operating system whichever you are running on your physical server. On the physical server, you can simply use that operating system and you can run the applications. So that is what I am trying to say. A container is a lightweight unit that packages an application and its dependencies. So I want to run some Tomcat. So Tomcat is a web application. Okay. So if I want to run that Tomcat in the back end, I need to run Java. So the dependency is there. And that Java should be running on a what I can say on an operating system like Ubuntu or else Windows, like that, or any operating system. So if you see here, a container will have all the dependencies packed, but it is lightweighted. So we don't need to install an operating system. Okay. So containers share the same OS kernel but runs independently. So if you see this container is having Java. On the top of that, it is having Tomcat, and the base OS is Debian. So here you can ask me, sir, you are saying about the OS, but you are saying that OS is not installed. Yes, OS is not installed. You will have only the basic operating system. Okay, not the entire whatever the operating system that you are seeing. So when we install the operating system, the operating system itself will consume some 30 GB of storage space in your computer. But if you see a container, let me show you my uh, Docker desktop there. Okay, I didn't install that. I will install it. Let me go with the installation procedure in the next day. So in the in the Docker desktop, what I can do, I can pull the Ubuntu image. That Ubuntu image will be some 100 to 200 MB of space only. Okay, so if you see a normal operating system, it will be some 20 GB of space, and when you come to the normal container operating system or else container package, you will have the operating system which is of somewhere around 100 MB, 170 MB, which means that it will only have the binaries and libraries. Apart from that, it is not going to have any sort of applications. On the top of that, you can run Java. On the top of that, you can run the Tomcat. So if you see the entire application will be available for you with the operating system within some 500 MB of space. So which means that we are we are creating a lightweight environment so that these containers can be moved from one server to the another server very easy. See, if I want to move one virtual machine, so the virtual machine will have its own operating system, own applications. So there will be some 50 GB of data should be transferred from one server to the another server. But when you come to the container is within 1 GB. So it is very easy for me to transfer this container from one server to the another server. So that is what they are saying: lightweight and efficient, fast to stop and fast to start, and easy to scale. If I want to increase the number of containers, I can scale up, and I don't want those many number of containers to be running. I can scale down within by giving a single command. So I will tell you about these scale up scalability. But the point what you need to understand here is the containers are lightweighted and they can run the application within a small amount of space, and they can be scalable. Okay, and when you come to the cons, shares the OS kernel, so less isolation compared to the VMs, less suitable for running a different types different operating systems. So if I want to run a Windows related container, it will be very hard for me to run the Windows related container. Okay, that will be the main disadvantages with the containers. But when you compare to the cons, you have to take consideration of the pros. Okay, what are the advantages? The advantages of lightweightness and transferring from one server to the another server will be very easy, and creating the container itself is very easy for us. So if I want to create a virtual machine, first of all, if you see why I did not, first of all, I need to go for create a virtual machine. For example, I want to create an Ubuntu server. Okay, here I will come back and I will select the Linux operating system and I will select the Ubuntu, next, and then next. I'm not creating, but I'm just showing you. Just now I have created a virtual machine. Okay, so I have a virtual machine which is a Ubuntu virtual machine. So inside that I need to install the Ubuntu operating system. I need to find out an ISO file where it is available, and then I have to download that ISO file, and then I need to install it. But if you go back to the Docker, I don't know, the Docker is, I think I did not install the Docker on my system. But anyways, tomorrow I will install the Docker on the system and I will explain you about the Docker desktop. So it is just 5 to 10 minutes of time to run a container. Okay, so that will be very easy to spin up the containers rather than spinning up the virtual machines. So that's the main drawback of your virtual machine, where it will become an advantage to your container. Okay, so now do you understand the difference between VM and a container?
Sir, quick question here. So can you show that like the picture for container once more, like the slide?
Okay.
So like where I am confused is like
Hmm.
we have three separate container and the base of that container is one OS, like kernel, either no matter it's Linux or anything, right? That container PPT,
Yes.
please. Yeah, this one.
Hmm.
So we have three containers, but like three container base is on the kernel is any of the like Linux or any of the operating system. On the top of that, there are three container, right, sir?
Yes. Yes.
And then this Debian Ubuntu Alpine is like this is you said like this is just the image of this operating system, right?
Yes.
And on the top of that image, we are hosting our application, right? On the Tomcat Ubuntu. Is this something, did I understand correct?
Yeah, correctly. That's right. Yes, exactly. So what's the question now?
So the question is, like, let's say on Ubuntu, like, I'm just curious. So can we run any of this, like, let's say software, like in Ubuntu, Open Office Libra on the top of Ubuntu, maybe any play
Yes.
any music file or anything like a video file on Ubuntu on the top of? Can we do or not?
Yeah, you can do that. You can install anything, but that is not the requirement, right? So to run the
Yeah.
video files and audio files, we don't use the. These are
Mm.
like the professional. If you want to run, so if you want to run the video files and audio files also, that will be running, but that's not the case here. Okay.
Yeah. Basically, the goal is to deploy the microservice based application. That's why we are creating and working for the container, right, sir?
Yes.
Yeah, yeah. Okay, okay. Yeah, got it, sir. Clear. Thank you.
Welcome. Any questions? Any another questions? Am I clear with the entire topic? What is the main difference? If you understand the main difference, so tomorrow we will start the Docker. So
One thing
tomorrow,
still I didn't understand. You said like it's easier to, something like migrate to containers to server means what? Like how do it's confusing.
that
Can you
that that you will understand once you get into the Docker. So how it will be very easy. I said you the word itself. It is very easy for us to migrate. But if you
okay.
want to understand that, how I can convert this container into an image format and how I can migrate it to another server, that you will learn once you step into the Docker concept.
Okay, sir. Okay. Thank you. Thank you.
And Chaitanya, like I have one question that in case you are creating a container which is like Ubuntu based, okay, so do we need to have the base kernel for Ubuntu only, or can it be used like CentOS kernel can be used?
See, now I am so now I am having a Windows operating system. Okay, so for
Hmm.
this Windows operating system, the kernel is different when you compare to the Linux operating system,
Right.
right? But still, I can run the Ubuntu containers on the Windows operating system itself. They are going to take the Windows kernel. So, what is a kernel in general? Any idea about that?
Yeah, yeah. Basically, it's part of software which is communicating between hardware and the user.
Exactly, but that is not a software. It is like an operating system management software, I can call it as. So
Yeah,
it will be an interface between the operating system and the hardware, not with the user and the hardware. So the user will interact with the operating system, and operating system uh, will interact with the kernel. For example, I want to open one file. For example, I want to open Google Chrome. So when I double click on that, first what happens, the operating system will talk to the kernel. So a user want to open an application. So now kernel will provide certain amount of memory. That is, memory management will be done. And then at what time the application has to be opened, and process management. And then if at all there is any network management has to be done. Those are all the things that will be taken care by your kernel. Okay, so kernel is just an heart
yeah,
of your operating system. What should be happen and what time it should be happen, and where the application has to be stored, and so this communication will happen between the operating system and the kernel. But if you see the operating system, Windows operating system will have a different, see, uh, what I can say, for example, there is a translator. Okay, there is a translator. Suppose PM has came to one of a meeting. Okay, so he came to some Andhra Pradesh. So there people will talk only Telugu, but PM doesn't know Telugu. So what you will do, you will have a translator. So in the same manner here, my Windows operating system is there. It will have its own kernel. So it doesn't require any translator. But when I am running an Ubuntu container on the top of my Windows operating system, I need to have a translator that is called as WSL, Windows Subsystem for Linux. That we will install tomorrow. Whenever I am installing the Docker desktop, I will clearly explain you about the this WSL concept. Okay, how we are going to install that? If we run the WSL itself, we can run the containers directly. Okay, so Ubuntu containers and everything. So this
Directly on the
WSL,
Windows, directly
yeah,
on the Windows
exactly,
system, right?
directly on the Windows system.
Yeah. Okay.
Okay. So this will help you to establish the communication with this Ubuntu containers can communicate with the Windows kernel. With the in between, you will have this WSL. So it will communicate on behalf of the Ubuntu. The WSL will communicate with the kernel, and kernel will provide the resources to your containers. Okay, am I clear?
Yeah, got it. Thank you.
Any further questions? Okay, fine. And guys, I want your mobile numbers. Why? Because just to have a call with you. Okay, either my team will call you. So please provide your proper mobile numbers. It won't take more than 2 minutes to talk with them whether are you interested to join in the sessions. Apart from that, they are not going to ask you anything. So I just want your feedback, like for what happens. They will call you on that. Just attend the call, or else provide a proper number. Some person has not provided the number itself. They have given only a single digit. So it is for your sake only. So Durgasoft will call you just for your feedback and just to know whether are you continuing the course or not. So that we will have a clear cut understanding how many people are attending to the next session and how many are not. So that will be helpful for me. Okay, so please, if Microsoft calls you, if you get a call from an unknown number, please try to attempt that. Either it might be from the Durgasoft. So they are going to ask you whether are you going to continue or not. So tomorrow and day after tomorrow you will have 2 more sessions. With that we will wind up the demos. Once the demos are done, then we will be diving directly. So of course I am going to see here, demos means I am not going to repeat everything. So previously, yesterday I just gave you a glimpse. I did not repeat it today. Today I have gone to a basic concepts. Tomorrow also there will be basic concepts. So for you it might be a demo, for me it will be the original normal classes that I am going to take for you. Okay, so treat like that. So don't consider it as a demos. These are the normal classes which we are continuing. But for your perspective, for your understanding how the trainer will teach you or else train you, for that you can take these as a test cases. And later on, when we go on from Monday, you can directly dive into the concept. Okay, so tomorrow also we will have the basics
Yeah,
itself.
sir, I have one question. So, since I missed to attend the class yesterday, so will there be recordings available on the daily sessions, sir? Whenever we miss by chance,
You
can
will have,
we go back to that?
you will have.
So, how long we will have the access to that?
It might be somewhere 6 months to 1 year, I think.
Oh, okay. And also, do we get any notes to refer?
I will provide you the document. Don't worry about that.
Okay, and will that be like advancedly given, or which we can go through and come back, or will it be after the class, sir?
Will be after that session. See, if I give the entire document right away, so there are the people who will go through the entire document and there won't be any excitement. So there are a few people who will understand the document and there are a few people who doesn't understand the document. So they will understand half and they don't understand the other part, and they will come and they will keep on questioning the class. So I don't want that to be happen in the session. I will provide you the document once the classes are done. So after checking the classes, if you go through the document, then you will easily understand what is there in the document. Okay.
Okay, thank you, sir.
Okay, guys. Fine. I hope I have made everything clear for you. So that's all from my end. And tomorrow also there will be a demo. And please answer if someone calls you from Durgasoft. They might be calling you just to know whether are you interested in joining the session, and please provide the proper mobile number so that it will be very easy for us to trace you in the sense just to call you whether you are you interested or not, and to find out if there are any further slots are available for another people. Okay, See,
Yeah, sir, one more question here. Sorry, since I missed yesterday, so will we be covering Jenkins also, sir, here?
that is what Jenkins, in the sense, try to understand. Uh, First things first, Jenkins basics will be covered. Okay, that will be discussed on the Kubernetes. Okay, not the entire Jenkins part. So how the Docker, how the containerization will use the Jenkins, that will be covered. Okay. This is not an CI/CD, what I can say, tutorial or else training session. This is the containerization training session. So a basic Jenkins will be implemented for you. I will train you on that.
Okay.
Yeah. Okay, guys. Have a nice day, and we'll meet in the next session. Bye.